Hey everyone, good morning. Woo. Wow, this podium is really tall. I actually can't see over it too well, which probably is actually a good thing. Thank you so much, React Rally, for having me here today to talk about D3 and React. My name is Shirley. I'm a freelance software engineer, and I build data visualizations. Thank you. I build it for product, I build it for story. I mostly use D3, but most often my projects are with D3 and React together. So when I mention D3 and React, the most common question I get is, how should we use them together? Who gets control of the DOM? And I want to kind of rephrase that question a little bit to, who needs control of the DOM? After all, with React, we have the virtual DOM. So if we wanted to keep track of updates, then we need to give it access to the DOM. And D3 does visualizations in the web. So of course, obviously, it needs access to the DOM, right? But actually, D3 actually only needs access to the DOM in 3 different places. The first being with transitions, which are animations between one data set to the next. And what we do with this one is to tell D3 the attributes that we want to animate. So be it X and Y positions, radii, fill color. And then D3 takes that and calculates all of the in-between states for us, all of the interpolations, and then updates that directly to the DOM so that we don't have to. The second is with axes. So with axes, it's quite a repetitive task to every single time have to make the little ticks and the little text. So we tell D3 what we want, and D3 goes and renders it directly to the DOM for us. And finally, with brushes. So brushes are similar in that it's really repetitive if we have to every single time define the brushable area, make that little box thing that's moving, bind all of the events. So we tell D3, and D3 goes and does it directly for us in the DOM. But the things that we most often associate with D3, things like layouts, so that could be the force layout, that could be the chord diagram, circle packs, tree layouts. With geo, projection, mapping, shapes, so that could be line charts, area charts. With all of those that we so commonly associate with D3, we don't actually need to give it access to the DOM. What actually happens is that we give it data, we give D3 our raw data. D3 takes that data and calculates and gives us back data, that same data, but now with the appropriate information on top of it, so that we can use that information to render the visualization to our browser. And that, to me, is really the power and magic of D3, which is that it helps us transform raw data, let's say average temperature of a city across time, and translates that into screen space, whether that be your X and Y coordinates, your radii, your colors, whatever that might be. So the way that I like to think about D3 is that it helps us calculate, it helps us abstract away all of the really repetitive tasks common in data visualization for us. Which means that for most of our use cases, we can have D3 do the calculations for us to render the visualization, and then we let React do the actual rendering. The only time we need to deviate from this is when we need D3 to do any of the things that I mentioned before, with transitions, axes, or brushes. In that case, we can let D3 do both the calculations and the rendering. And then React can just kind of hang out in the background for structural support. So before I get into the how of using React and D3 together, I actually want to take a step back and ask the why. Why are we trying to use React with D3? Because if our goal is to build just a visualization, then D3 is actually more than enough to do the job. So for example, this is a visualization I did last year of all of the top summer blockbusters of the last 2.5 decades. All of the petals, the shape of the petals are the parental guidance ratings, the colors are the genres, the number and size of petals are the IMDb ratings out of 10. So I have some favorites in here. I think The Dark Knight Rises is really beautiful. I always love Harry Potter, and I think Inception is great too. But my absolute favorite out of all of this is the 1997 Batman and Robin, because I think it's so adorably tiny and cute. But anyways, so the only interaction I have for this visualization is a click interaction to open up the corresponding IMDb page for that movie. So the next example I have for you is this one. It's a visualization of 4 years of vacations in 20,000 colors. So I basically went through all of my vacation photos in my past years, took the five primary colors out of them, grouped them by the trip that it was taken in, and arranged them by the date that it was taken in. So I learned a lot about myself with this visualization, which is that I knew already that I really liked taking pictures of nature, so, water and sky and trees. So all of these blues and greens made a lot of sense to me. But I was really confused about the reds and purples because there's no way I'm waking up for enough sunrises for this. And I looked into my pictures, and I found out that all of these reds are actually food pictures. So this is what I'm saying. I learned a lot about myself with this visualization. Because you can tell this is the time when we went to Japan, and apparently all we did was eat. And this is our Europe trip where we spent majority of it in Iceland, so there's a lot of blues and greens here. And apparently, again, all I do in New York is apparently eat. So, but you might have noticed that the only interaction here I have here is a hover interaction. So the way that I like to think about it is D3 is more than enough if the visualization I'm trying to make has only a hover, click, or other simple interactions. But if I want to take these interactions a step further, if I want to make whole UIs around my visualizations, or even multiple visualizations, then React comes in extremely handy. So take, for example, this really simple example app I made to show React and D3 together. It's an expense app where each of these little dots are an expense, and these are categories. And I've grouped the expenses by the date and each of these blocks, so these blocks are the dates, and the background colors are how much I spent in total that day, with the greens being the ones I spent the least, so good job to me, and the ones in red being where I spent the most, not good. And I can toggle through each of these weeks. I can hover over an expense to see what it was, and this was an Airbnb, so then I can drag it over one of these categories to link them together and categorize that expense. And of course, I can do the same thing to unlink it. I can drag an expense to another date, let go, and edit the date of that expense, and that will change the background colors of the dates accordingly. I can add a category, and this is my favorite interaction I implemented. So I can add a category. That was really fun. Do you want it again? I got really excited when this worked. Thank you. Oh, thank you. Thank you. And then I can drag it to also delete it. So I learned also a lot about myself with this one. So these are actually my own expenses. And apparently, I drink a terrifying amount of boba and milk tea. So with this example, I use React to manage updating my visualizations on each user manipulation of the underlying data. I also last year got to work on this project, where we visualized viewer brain data as they watched the final presidential debate. This is the most political I'll get in this talk. It will not be political. So this is the timeline as the debate happened. The background colors are who was speaking. The waves are viewer engagement as the debate is going on. And let me note that it does not mean a positive or negative reaction, it just means that they engaged. Because what we found out was that, scarily enough, people's attentions, engagement spiked up when Trump was speaking, and it dipped whenever Hillary started speaking. And at that time, we didn't know what to make of it. And a few months later, after the election, we looked at this again, and we were like, this is really creepily, scarily accurate. Anyways, so we can drag this around to drag the brush around the timeline to dig into any 15-minute increment. We can select any demographic group, and then we can dig into this area to see the details of who's speaking and what they're talking about. So for this example, I'm using React to link multiple parts of my visualization together so that on a user interaction of one part of the visualization, the rest of the visualization will get updated accordingly. And finally, I have this example, which is an interactive visualization of every line in Hamilton. Thank you. That was why the music earlier was a mixtape. I got so excited. Actually, by the way, let me just say, giving us the choice of a background music is like the hardest thing I had to do preparing for this talk. I was like, I don't know. But finally, I chose one. Yeah, thank you. Anyway, so for this one, as I scroll, the dots are actually lines in the musical. And as I'm scrolling through each section of my analysis, it's highlighting the appropriate song that that section of analysis is talking about. And at the very end, after all of the analysis, I give the user an exploratory tool so that they can, for themselves, filter by any set of characters, any set of conversations, and any of the recurring phrases and themes that might have occurred in the musical, and dig into the remaining lines and songs to do their analysis. So for this example, I use React to manage that initial scroll and the final exploratory tool at the end. So the way that I like to think about it is I use React with D3 when I want to componentize my visualizations and when I need to manage state as the user interacts. So now that we've figured out the why we need to use React and D3 together, I want to go back to the how. How should we use them together? And the way that I like to think about my visualization components are that they are self-contained components, where if we pass in raw data, that component will translate the data into screen space, render the data, and manage interactions with the data. So let's take a look at this really simple example of a graph. All I have for this is an update where it changes the graph. And I can also select a node to highlight, so update the opacities of its neighboring nodes and links. And that's all this does. So let's start with the code where D3 is doing all of the calculating and React is doing all of the rendering. So this is the whole code. I have an app component, and I have a graph component. The app component is in charge of, it has the graph component and the update button, and it's in charge of getting the data and updating the data on user interaction. And the graph component is in charge of, takes care of when that data comes in from the parent, it takes care of figuring out the X and Y positions of the nodes and links with a D3 force simulation layout. And so here, one of the best practices I've developed through the years is I like to keep a very, very clear distinction between my graph component, my visualization component, and it is in charge of only the data calculations necessary and relevant to rendering my actual visualization. And any other data calculations and edits I might have, I have it outside of my visualization component, in this case with my app component. I take that data that I just calculated and I loop through it and return a set of SVG circle and line elements, and I return that in my render function. And of course, I want to point out that the data calculation needs to happen before the render function in the React lifecycle. In this case, I do it in component will mount and component will receive props. And a note on performance, I really like putting the data calculation in component will receive props because component will receive props is only called when the parent passes in new props. Or the other way I like to think about it is when the user has interacted and updated my underlying data. And it does not get called when setState is called on the component itself. So that helps me avoid unnecessary data recalculation. And it has the added benefit of if at any point I want to set state on after my data calculations, I can set state without triggering an extraneous lifecycle. So for the interaction of selecting a node and highlighting my neighboring nodes and links, I simply set the node data on the component state, and I do my calculations, the actual calculations of figuring out which nodes and links are the neighbor of that selected node in my render function so that I can use it and set the opacity of my SVG circles and lines in my render function. So the key thing to remember when we are using React to render is that if a user interaction does mutate and update the data, propagate that data from the parent, and calculate that data in the component will receive props. If instead the interaction does not mutate and edit the data, set state in the component, and calculate it in render. So let us take a look at D3, that same example, but now with D3 doing the calculating and React doing the rendering. So here's the code. The app component is exactly the same as before, but the graph component is very different. And the biggest difference is in the render function. Now, instead of returning my nodes or my circles and lines, I instead return an empty container element. And in component in mount, I take that container element, I wrap it up in a D3 selection so that I can use it later on in my D3 render code. And also in my component in mount and component in update, I call all of my calculate and render functions for doing my visualization. And sorry, what? Oh, yeah. I actually don't think I can. It's, yeah, I seem to not be able to just because of how the presentation is set up. Sorry, what? Oh, I'll upload it later on my Twitter. And it's also on my GitHub as React-D3. Yeah. Oh, and the examples are also, I'll put the examples also online. So I'll link everything. Okay, so what was I saying? Oh, okay, so I was saying, so calculating the graph, so calculating that data of the X and Y positions for the nodes and links, that function is exactly the same as before. But now I've taken the calculation of which nodes and links to highlight, the neighboring nodes and links for the selected node. I've taken that out of my render function, and instead I now call them in my component.mount and component.update. So that in my D3 render code, I can use that data to figure out the opacity for my circles and lines. And I do my D3 enter, update, exit pattern in these render functions. And one of the best practices that I've established for myself over the years is in this render code, I want to define with my D3 code exactly what my visualization should look like, given any data or any component state. Just like how I would think about what a render function will return for React. And this is so that if I want to implement any other features or interactions in the future, all I have to do is write the code to update the data or manipulate the data, and then the visualization will render exactly how I want it to with very little additional code. So here's the interaction of selecting the node, and it looks exactly the same as prior. But one of the things I really want to point out here is when I first started doing this, I was always really tempted to put D3 code into this event callback. I was always really tempted to put, in this case, to have D3 update the opacity of my circles and lines directly into this click event callback. But over the long term, I realized that it's much cleaner and simpler for my code if instead I only set my node data, only set state in this function, and let the lifecycle run so that I can take advantage of the component.update function that I've already set up to render the right visualization for me. And a final note on performance. So I often like to use should-component-update in this approach if I have interactions that might not need a whole recalculation of my data or a whole re-render enter exit of my visualization. And instead, what I do is do the subset, the calculation, do the subset of the calculation that I need, and only update the parts of the visualization I need to. So in this case, I only calculate what needs to be highlighted, and I only update the opacity of my nodes, of my circles and lines when the user has selected a node, and then I return false to cut off the rest of the lifecycle. So with D3 rendering, I define exactly what the visualization should look like in my functions and call that from my component.mount and component.update. And most importantly, I never, ever, ever let D3 and React control the same parts of the DOM, or else heinous bugs for a whole afternoon. So after all this, you might be like, WTF, Shirley? Like, this is basically everyday life for me. I already do all of this. I already go through this exact whole thought process while I'm building my non-visualization, non-D3 React component. What gives? And you're exactly right. But that's also my point, which is that as front-end devs, the design of data visualization might be a little bit foreign to us. But the implementation, the coding of it in the browser is not. It's just like any other UI project. the thought processes that we go through is very similar. And so when we talk about the how of D3 and React together, there's already a lot of really great, years of really great resources, writings, libraries, components out there. But for some reason, we still haven't seemed to have agreed on the one best approach. And I think that's absolutely okay. Because to me, the important thing is that you and your team agree on the one best approach for you and your project. And that brings me to my final point, which is that I'm really, really excited. I'm really excited as we go forward because now that data visualization has been in the browser for quite a few years, I'm really excited to see what can we take from everything that we already know about building UI with React or any other framework, and what can we take from that and apply it to D3 and data visualization, and vice versa. So I'm really excited as we go forward, and I hope that we'll stop talking so much about the how of using React and D3 together, but instead that we will start talking and working on the what. What can we build with D3 and React together to push forward the practice and the fields of user interaction and data visualization? Thank you so much.